Hello, welcome to my object-oriented programming tutorial. In this tutorial, I'll guide you through the world of classes, objects, constructors, till the pillars of OOP like inheritance, abstraction, etc. This is Rahul Sriram, a 19-year-old budding YouTuber, and I welcome you to my channel, The Skinny Coder. Before diving into this tutorial, I assume you have basic knowledge about programming in Java, because that will be the language we'll be using. You should have clear understanding of operators, primitives, conditionals, main method, PSVM, etc. etc. I also won't be dealing with JDK installations and IDE setups and editor setups and all, because I'll be just using Java as a tool to explain OOP, and this tutorial isn't a crash course on Java. Okay, you can use any object-oriented programming language to follow through this tutorial. Okay, there are many classifications in programming paradigms, but essentially speaking, these are the four. The first one is procedural, which is a step-by-step or line-by-line execution. A famous example is C programming language. Then comes object-oriented programming, where it deals with objects and classes, about which this tutorial is about. And some examples are Ruby, Java and all. Then we have functional programming languages, or the functional programming paradigm, which deals with immutability. It is very similar to Turing machines, if you know, and a very good example is Haskell programming language. Then comes the logical programming paradigm, and I don't know what it is about. So the first two are known as imperative programming paradigms, while the later two are known as declarative programming paradigms. There are also some multi-paradigm programming languages like Python and JavaScript, which have a combination of all these four and all. But this tutorial's goal is to dive deeper into the world of classes and objects, so let's dive in. What are objects? Everything around you is an object. Like, for example, my algorithm's textbook, or my blue pen, or an elephant, or a kidnapping van, or even me myself. Everything is an object. For example, consider Jesse. He has got some unique properties for himself, like he has 2 eyes, and he's not having a beard, and his first name is Jesse and the last name is Pinkman, and these are particular to him, right? Like, these can be copied, but that doesn't mean that there is a single Jesse, though there are 2 of them existing. Even twins are not identical. Not only having properties or having stuff like this, Jesse can do stuff too. He can perform some actions too. For example, the famous dialogue of him is, "Yo, Jesse Pinkman in the house, bitch," right? That is an action. Similarly, every object in this world has got some properties. While writing in code, we generally denote each entity in this world as an object in object-oriented programming, and every object has got some properties like this, which are known as fields. They possess, that particular object possess, and every object also can perform some actions like this. This is the data that we'll be having, and this over here, the methods or the actions that we provide to an object are what that object will be doing using the data. For example, using the first name and last name data over here, a dialog is being given out as an output. If you can observe, we have strings, we have numbers, and we have booleans, and we can also have other objects. Everything can be stored in properties, okay? And we can use all of them in our actions too. In programming, we call these as properties or attributes or fields, and we can also call these actions as member functions or procedures or methods, okay? So mostly they are called methods or member functions. Similarly, consider Walt. Even he has 2 eyes, he has got a beard, and his first name is Walter and his last name is White. And his famous dialogue is, only he can do that. Now even here you can see we can store strings, numbers and booleans, and we have the same method as Jesse does. To embed such objects, like for example, Walt is an object and Jesse is an object. Let us assume you're creating a Breaking Bad API. Okay, and you want all the characters of it stored in your database. To embed such objects into code, we can create 2 different entities for both of these characters, right? But don't you think we are repeating a lot of code? While creating Walt, you're redeclaring the first name field, the last name field, the number of eyes field, the has beard field, and then you're getting into the dialog function. Those are already being declared over here and defined over here, right? But you're again doing it that to create another object. Where is the try principle? We are not at all using the try principle. That means don't repeat yourself. Like, they're humans, they'll have common properties in them, right? And what if I told you I want to involve all the Breaking Bad characters into my API? So that will be hell lot of a repetition. Here is where the concept of classes enter the play. Since all humans are similar, why don't we have a blueprint with similar properties pre-declared into something called as a class. And when we create multiple objects using that blueprint, we can assign the preferred values to those properties, and the predefined methods acts accordingly to the values of that particular object. For example, instead of creating two objects like Walt and Jesse as separate entities, I created a common class or a blueprint called human, because those both are humans. And classes or these separate blueprints will have properties or fields or attributes, which is the data that we want to store, and they'll have some actions they can perform, also known as member functions and methods. Okay, this will be using the data we store over here. We'll be just declaring what kind of data we'll be having. For example, first name and last name strings will be there in an object which will be created using this blueprint. There will be a number of eyes, and that will be an integer. You can't just pass in a string over here or something. Or has beard will be a boolean value. Either a human object can have beard or it won't have beard. That's all. Those are the only two probable variations of that property over there. And even the dialog thing is defined over here. Okay, based on these keeps changing between object to object. For example, take a civil engineer. Okay, here is a civil engineer, and he says every building has got a color and a height. Okay, but he uses the same blueprint. You can see I made it look like a blueprint by giving it a color of blue. I don't know if that's looking like a blueprint. He created two buildings using the same blueprint, but the color of the first building is blue and the color of the second building is yellow. And even the heights differ. The height of the first building is 90 feet while the second one is 70 feet. He has got a construction blueprint and he constructs buildings based on that blueprint. Though they are of the same structure as the blueprint defines, they might have different properties like height and color. This is the blueprint or the class over here, and these are the objects that are being created using this class. And each object will have their own values for these properties. The properties are same, but the values stored in those properties are different. That is the difference between object to object. That is why objects are unique. To sum up, classes are ideal. That means they doesn't exist in reality. We declare what properties will be there inside a class. For example, in the blueprint, we give a statement that there will be a color for every building, there will be a height for every building, or every human will have a first name and last name strings, and they'll have an integer called number of eyes, and they'll have a beard or they won't have a beard. Only declarations are being done when it comes to properties. And when it comes to methods, definitions are being done. For example, if you see the dialog, we give the definition over here directly. Okay, so method definitions and property declarations, and these are ideal. They doesn't really exist in the real world. Whereas objects, these are real instances of the classes. These are real. They do exist in the real world. As I told you, everything in this world is an object. We can consider everything as an object. And objects are also often known as instances of classes. Okay, every object is unique. Though using the same human class, if I create two objects with the same first name and last name, with the same number of eyes, and with the same value of has beard, then you get the methods. Everything is the same, but yet those two objects will be different because of their memory allocations or where they are stored. Okay, even identical twins are not the same, right? You can't consider them both as the same person. They are different. That is why objects are always unique. No two objects in this world are similar or identical. Okay, so objects are unique and they are similar in structure and type of properties and methods. What are the types of properties they are having? They are having a first name property. Every object of human class will have a first name property, a last name property, a number of eyes property, and has beard attribute and all. Okay, and they can have a dialog method in them. So they'll have a similar structure and types of properties and methods. Only that is similar. But what are the values stored in those properties and how methods differ and how methods behave due to those difference in those properties is different. For example, if you can see the same properties are being defined for Jesse and Walter over here, but the dialogues will differ and even the values stored in those properties differ. This process of creating instances of classes is known as, or the process of creating objects from classes is also known as instantiation. So in the next video, we'll be using Java programming language to instantiate some objects, and we can also go deeper into what is the new keyword and what are constructors and all.